My name is Michael Shengeli. I'm the head of content strategy here at Eagle Alpha, and I'm delighted to welcome speakers today. Rohan from Sphinx AI, Wilson from Permutable AI, and Vibhav from Pascal AI. We run these workshops every month on various topics across strategic insights, use cases, legal and compliance, also technical insights. We just had a webinar last month on disruption across software industry, AI Mageddon, as they call it, and we will have legal workshops coming up soon on latest changes in China and cross-border data transfers. We will send updates in the coming weeks. And without further ado, I want to invite Rohan from Sphinx AI. Rohan, can you hear me?
Yeah, can hear you.
Perfect. Let me just share your screen quickly. Um, you can begin now.
Can you guys all hear? Can people hear and see me, or just hear me?
There's no video, say
Yeah,
just the
no
voice.
worries. Okay, perfect. Yeah. Well, I appreciate everyone coming to this talk, and appreciate the other speakers as well. So I'm Rohan. One of the founders and the CEO of a company called Sphinx AI. And what Sphinx broadly does is we think about the problem of building specific intelligence on your data. What we found broadly, and most of us have an investment background, including myself, is that often AI understands very generic problems quite well, but when it comes to bringing data to the financial markets, especially when working with things like alternative data or market data, there is a lot of unique understanding that each investment team brings. And that unique understanding is exactly where the alpha is. If you just kind of have very generic understanding, the same kind of understanding that ChatGPT or Claude may have out of the box, you're likely not going to be making better decisions in terms of how to allocate capital compared to just a person on the street. But again, at most institutions, there are people with theses that need to be captured, and AI doesn't yet understand them. As terms of background, I'm a quant by training. I spent many years at Citadel, where I ran a team that focused on leveraging what at the time we just called machine learning, and then later was renamed to generative AI, to drive investment decisions, mainly in the equity space. We found over the course of many years trying to build with agentic AI and its predecessors, that the biggest challenge was not getting models to be smart at math, not getting models to be good at modeling or at building scenarios out, but really at understanding the core DNA of a business, at understanding what is it that we think about this data that's different than everyone else. How is our data laid out? What data do we have available? How do those pieces of data interact with each other? What are the right metrics that we care about? Is it like, how do we measure success? And then getting all of that enterprise specific knowledge into these agentic systems was the core driver of allowing them to make good decisions. So we are a team based in New York, all ex-finance people for the most part, and we focus on building what we call the knowledge layer. It sits basically squarely in between your intelligence layer, which almost everyone has already, which are things like OpenAI, GPT, Claude Code, Codex, whatever you might want to use. And your data layer, which is going to be your Databricks, your Snowflakes, your Mongos, places where you're keeping raw information or information that's coming in from the various vendors that you're buying data from. You probably have terabytes of data coming from vendors in certain cases. You from like, various different credit card, geolocation, whatever web traffic data, it's all being pulled in. It's all stored somewhere, and you have AI that can, in theory, access it, but doesn't really understand how to use it. The human and institutional understanding around that data is the really critical part that we believe unlocks actually having AI act as a thought partner for investment teams in particular, where there is so much nuance around the data, how it's used, how it's transformed, how it's cleaned, how to turn the raw data coming from a vendor into a signal that can actually be actioned. So in terms of like why I think this problem matters, this is we see ourselves as a research team, right? We're all a lot of quants, so we like our numbers. And in terms of how we validate something like this, the first and foremost thing is something like correctness, right? We see that when augmented with a knowledge base, even very powerful AI agents like Claude. Claude Code, with some of the more newer Claude Opus models that have come out recently, are able to do significantly better on standardized data science benchmarks. This is one called Krama Bench that came out of MIT. It's around 1,700 different data sources, and they have hundreds of questions on these data sources. And the idea is to basically simulate what it would look like in a real environment, like, for example, at an investment firm where you're bringing in tons of different types of market data, alternative data, et cetera, and asking complicated questions across all of them. Are you going to be able to get these questions right? Are you going to be able to answer accurately? And the answer is like largely like not really, even with very powerful AI, unless you build knowledge of how that data works, how it interoperates, and how humans kind of have built understanding on that over time within a certain organization. I'll kind of augment this with some results that actually came out of Anthropic earlier in the week. Anthropic themselves have actually been working on their internal teams that do analytics on their own work and capturing how their agents can interact with their own internal data. And they found something quite similar to us. They found that their agents alone were able to answer only 20% of internal data questions correctly. But when augmented with hand curated knowledge, they got that up to 95% accuracy. So the real core thesis here is that it's not enough to just have data as an investment team. In the age of AI, you also need the context layer of how that data makes sense in order to actually get something that's accurate and repeatable. The other angle here that's becoming increasingly important is token costs. As people let agents loose on their data and let agents loose on their theses, we're finding that costs are exploding. People are often paying hundreds of dollars just to kind of get some like reasonably weak conclusion because the agents just will go look at a whole bunch of information and not really get to anything productive. But again, with the right knowledge layer, agents can be targeted to find the right thing quickly. Um, So yeah, in terms of what Sphinx does, we are effectively a three-part system. We take in any specific knowledge that you as a company have built. These are going to be things like code, APIs you've created, dashboards that you're surfacing, notebook analyses that your quants or data team may have done, SQL queries, documented knowledge that you already have, things like vendors who send you documents about like how the data is laid out or what the data means. We take all of these and run training on them effectively. We have a process by which we reverse engineer any work that exists and learn the implicit decisions that were made when that work was created. These are things like how you normalize the data, how you use the data to build signals, how those signals flow through to investment process. And we capture all of this into a knowledge graph. That knowledge graph is continually updated. So as you continue to evolve your thinking, as your investors evolve their thinking, every single interaction with the system builds up momentum, builds up knowledge. And then that is then vended out to any agent you want. It could be a third-party agent like Claude Code. It could be an internal agent that your team is building. It could be a more standard software application that wants to access this as a sub-agent or as part of like an agentic flow within a broader product. And by doing so, we're able to take the knowledge that was implicit in all the decisions that were made by people like quants, like sector data analysts, like fundamental analysts, and capture those and then vend them to agents at the right time so that agents can start acting like subject matter experts as well. And that allows the agents to start to deliver a lot more value with a lot less handholding. Um, because this is a little bit more of a data focused audience, I'll kind of go into some technical details of where we see the real value of knowledge layers being. Um, Often we find that the way people think about their data and about how AI interacts with data is that you can just give AI a huge amount of content and let it kind of figure it out. And this is approximately true, but it's not really very effective. Going back to Anthropic's study that they put out a couple of days ago, they found that, again, as I mentioned, 20% of analyses were being done correctly if they gave an agent access to all their data. In fact, when they gave their agent access not just to the data, but to every single past piece of analysis they did, they found that that accuracy only went up by around 1%, so like 21, 22%. And that was because just giving AI access to a whole bunch of stuff is not the same as giving AI understanding of your thought process. That stuff may have traces of your thought process in it, but it's not the same thing. Some analysis may have been wrong, some may be outdated. So, what we see as the important thing to do here is to very specifically try to capture how you think about the world as distinct from how a general purpose AI thinks about the world. That is, in my opinion, pretty analogous to alpha at this point. It's like a view that you have that other people don't have. And if you're correct, you will be able to monetize that. The way we try to capture that technologically, at least for us, and there are other ways that people are exploring to do this, is that we believe that whenever a piece of work is created, especially an alpha generative piece of work, that piece of work contains some knowledge that is inherent to that alpha generator and some that's just generic stuff like, writing code, doing a regression that every AI already knows. We specifically try to capture that by doing effectively gradient descent, trying to see how would a generic AI replicate the signal versus how did this talented human or internal process create the signal, find the difference between the two, and then capture that difference. And by capturing those differences over 10 examples, 100 examples, 1,000 examples of work, we're able to build out almost like the mind map of how data and ideas flow through into decision making. Um, in terms of how we capture this and how we recommend everyone capture this type of information, Sphinx operates on a wiki ontology based model. We believe that in the past, when you had your Palantirs and others building ontologies to understand data, a lot of structure was needed. That structure came from a time when agents were not interacting with software. It was traditional programs interacting with software. In the age of agents, expressing things in natural language is incredibly flexible, incredibly powerful, incredibly easy for humans and agents to collaborate. So we optimize in that space as well. So when we learn how a company operates, when we learn how investment decisions are made, how when we learn how alternative data is leveraged uniquely at a certain institution, we capture that purely in natural language so that it's very agent native and agents can use that information immediately. And then more for the data management people here, we find that data knowledge, how you use the data, is as core a business asset, if not more, than the data itself. So everyone protects their data. Everyone has access controls on their data. They have very strict governance on their data. But the knowledge of how that data is used is increasingly turning into an asset which is not living in someone's head, but actually owned by a business. And so we also think about this problem here, where once we've collected the knowledge, how do you govern it? Who can access it? What's the life cycle? So if knowledge changes, who gets to approve that the knowledge has changed, or should we pin it back to the old version? How do we audit how the knowledge is created? Who created it? Who's using it? Why are they using it? What are they doing right? What are they doing wrong? How do we have collaboration at scale? And how do we make sure that there's a single global view that everyone can collaborate on rather than piecemeal views that then become siloed and wrong? And so we give you the controls you need in order to govern and audit this data landscape as well, the data knowledge landscape. Yeah, I mean, I'll wrap up by kind of actually, if we could skip this one, I only have a minute left. Yeah, so I'll wrap up by kind of walking through like what this looks like in practice for a very simple kind of investment use case, right? Um, if you go to Claude Code, and any of you working in financial institutions can go and try this, you go to your agent of choice and say, we have some credit card data, evaluate if it helps with revenue forecast. I mean, these are all like super complicated concepts, but they're expressed very simply by most investors, right? We have some new credit card data. Can you evaluate if it helps on revenue forecast? Well, what's a revenue forecast? What's my universe? What does help mean? How do I measure any of these things? These are concepts where if you go ask Claude, you'll get an answer. You'll get a different answer. If you ask it three times, you'll get three different answers, and none of them will really match what you want. It'll do things like running correlations in level space. It'll do things like not normalizing the data properly. It'll do things like showing like tickers that make no sense. And so here with Sphinx, what happens is, you ask this question, we consult the knowledge base, we generate some answers in view two, but more important than the answers is we generate why this answer was created, right? We have citations, we have evidence, we say we did an aggregation in a certain way because this is what's documented. We made sure we did it in quarter on quarter growth space. We made sure to join the correct earnings calendar that makes sense. We used the right fiscal quarters. We mapped everything correctly. And all of this evidence actually links back to something like a Wikipedia type page, which documents exactly how we think about it. Like, for example, earnings are documented as a table where we say earnings are a core table that reports quarterly results. This is what builds confidence in AI. This is what builds accuracy in AI. It's that your answers aren't just answers in isolation. They are cited, they are reliable, and they tie back to a global universal understanding of how the world operates, that is specific to your company and to how you think about data. By building these layers, we find that enterprises are able to capture their unique worldview. And while that's useful in a lot of domains, it's useful in places like retail, it's useful in places like tech. It is most useful in the financial domain, where you find that your unique worldview is why you have the right to make money. And so we believe that capturing this is the key to unlocking really agentic and autonomous analytics, quantitative research, fundamental research. I think I'm out of time, so I'll pause here, but obviously happy to take questions as we get into the Q&A session later today.
Thank you so much, Rohan, and fascinating lay of the land as well, and the amazing examples. Thank you to sticking to the time as well. I want to invite Wilson now. Wilson, can you hear me?
Yeah, yeah, I'm here.
Perfect. Just give me a second. You can you can take it away, Wilson.
Okay, excellent. Okay, good stuff. Right, so yeah, mine's Wilson. I am the founder of Permutable AI. We are a AI startup based in London. We serve predominantly systematic hedge funds around Europe and US. And our verticals is we focus mostly on commodities and macro systematically. So I guess the interesting thing is if we think about where we sort of started is we've pretty much been on the ML journey for the last 5 years as well, similar to the last host. And we've now come to this really interesting evolution where we now have to start thinking about what an agentic stack looks like and what are the real world examples of it. So in terms of the three pillars that we have here, we are focusing mostly on macro and commodities. The interesting thing is, I think what we've seen in the last 6 months is there is a huge amount of narrative and a huge amount of data and a very wide range of being able to interpret this data. This is almost perfect for an agentic framework to discover and analyze data and sort of deliver this concisely to the user base. The living world model that we do as well is we also build agentic simulators of what could be happening next. Very similar to what Palantir do. Okay. So yeah, so one of the big issues that we're seeing now is everyone has access to data. That's really not the issue. The issue is there are single points of decision-making process, especially by the trader and systematically. There are a lot of traders out there, or a lot of asset managers that can only trade once a day. So it really comes down to one decision point a day, and the question is, how do you make that decision? So how do you distill everything to a single decision? So the aim of Permutable really is not just to process the data, but to really try and understand what the outcomes of this is going to be and to really to make a decision. The other thing that we also do as well is we will also try and distill information in real time and deliver that to users at the appropriate time in a day. So that's number three. So so some of you may have seen a diagram similar to this before. So Anthropic released a website talking about at what point does AI become like self-improving. So if we look at the how the user engages with UIs or systems, if you start with search, for example, this is really kind of the Google search that we've seen up until maybe 2022, 2023. And chat now is the norm, shall we say. And I think the bits that we've really been stepping onto recently has been the agents and the multi-agent framework. So I think it's probably fair to say that we're only now starting to touch agent work, moving from chat. So I think for all those that actually are developers, the chat and the agent will be fairly mainstream for most people right now. The really interesting bit is can we really build a multi-agent stack that is capable of delivering production quality decision points and production quality insights? And one of the secrets for that, and something that Permutable is working on, is rather than waiting for something to go wrong live, we would always simulate this as a point in time framework. And I think for the systematics, this is obviously our bread and butter. We try and ensure everything is point in time. With LLMs, it's slightly more problematic because obviously LLMs have already been around really for the last 2 years. So it's quite hard to test an LLM going back 5 years. But there are frameworks that you can put together. The fifth one is autonomous. So I think this is really for us, it's kind of like the holy grail is, can you build an agentic framework that can actually self-improve based on feedback from the user and without like developer intervention. And I think this is going to be the really interesting place whether you can get these full-on assistants that can really take feedback and actually improve over time with no intervention from developer. So that's the interesting piece that we're going to be attacking later this year. Okay. So really, I guess the way we're kind of thinking about it is we deal with mostly macro data. Macro and geopolitics has been the biggest drivers for assets, we believe, the last 12 months. And the useful thing about agents is they are also reasoning models. So they can also not only take data and make decisions, they can explain at every point in time why it's made its decision. Now, what Permutable also uses knowledge maps and RAG systems, and what that allows us to do is allows us to trace all the data from raw data right to decision points. And if you're selling something to an asset manager, so for example, we were selling a UCITS compliant index. The rules of UCITS, for example, there needs to be a level of explainability in decision points, and that's something that we look at. The continuous and the agent ready is just ensuring that these systems are continuously running around the clock. And obviously, we are very mindful of agent costs as well. So the way we kind of protect that is we usually run, shall we call, scheduled frequent bursts of agent activity, and that's a way to sort of throttle the costings and to ensure you're not getting $500 million bill in a month. Okay, so this is a really interesting thing that we looked at. I think there's been a lot of terms, a lot of talk. Is the terminal dead? Is the UI dead? Um, we believe the answer is no. We think the terminal is just going to evolve. And there are 3 to 4 really big reasons why the UI is not dead. One is workflow. So workflow of a trader or as a user is so important. It's ingrained. You can take a very poor product like Microsoft Teams. Why does everyone use it? Because it's integrated into the workflow. So it just gives you an idea that even with a very weak product, a product that can be replicated, if it's built into the workflow, it's going to be very, very sticky. And the second one is human inertia. So so people don't want to talk to a chatbot all the time. A lot of traders just want to get data very quickly and they want to get it in a routine way. So human inertia is actually really important to serve as well. They want data very quickly. They don't really want to have to think. The third one is trust and verification. So we provide the user with the ability to trace back to raw data. We think that's really important, especially when there's accountability. Okay. And the long tail is, I guess, is while we do provide most of the terminals, we do have agents on top that will around the clock would actually read the terminals and actually invoke the user to look at the terminals at the right point in time. So we think this is like the perfect balance. So we really think this is a evolution of the terminal, shall we say? It's definitely not dead. So as far as we look at things is at Permutable, we kind of build three things together. So the terminal is really what we call the pull system. So the user will go to the terminal. You still need a canvas to really look at the data and to interrogate the data. That stays as it is. Okay. But then the other two pieces we're kind of building on top is the API allows machine to machine access. We would obviously put an NCP on top of the APIs for agents as well. But the really interesting thing that we've been pushing on top, what we call the push system. So this is the alert system, and the idea is that especially for a trader or for an asset manager, we would deliver data really at the right pieces of time or the right points in time, and we would deliberately try not to overload their workflow. And the idea is that if we think that we've got a piece of insight that the whole street or most of the street has not seen yet, we're going to raise that to the user's attention because we believe it's going to affect their workflow. Okay. And that's what we call the push system. So the pull system with the push system together is going to be a really good use of like agentic workspace. Okay, just to give you an idea of the kind of work that we do, we actually track all narrative data all around the world. We actually cover roughly about 250,000 sources. We're pulling everything in real time. And this example here is if there is a very interesting geopolitical event that's happening, we would actually track the coverage of this narrative over time. So this one, for example, is around the Red Sea shipping disruption. It's occurring over 6 hours. We believe that it takes roughly about 90, the sweet spot is about 90 minutes for a narrative to truly make its dent into the market. Okay. And we see this in the news build-up over time. So this is something that we study in our data. So we've got 15 years worth of data, real-time data, and we get to see these stories develop, and we get to see how these things really affect, in our case, the commodities market. Okay, cool. So I think the way we're kind of looking at this is we really try to deliver the understanding of the narrative. So firstly, we'll deliver what's going on in the narrative, but then we really look quite closely at cause and effect. And I think this is where the reasoning agents, and we call this the tip of the agentic framework. The tip of the agentic framework would have assessed all the data, would have actually made a very good reasoning narrative explanation of what's going on in the market. At the right time, we would then deliver this to the customer base.
Perfect, Wilson. Is
And I
that
think,
the end?
yes, and
Can you hear
that's
me?
it for me. Thank you.
Thank you so much for such a detailed presentation of interesting use cases as well, and how your process works. I see some questions coming in. We'll invite Vibhav now. Vibhav, can you hear me?
Yes, I can. Okay,
Perfect.
awesome. Thank you so much, and great to see and meet all of you in the audience and fellow presenters as well. Right, so I'm the founder and CEO of Pascal AI. We bring the power of generative AI and agents to investment management. So we work with hedge funds, asset managers, banks across the globe. So we are production grade. We power something like $1 trillion of AUM today. We see a lot of good usage across our deployments. So something like, we call it 10 queries per user day, but a lot of them are actually run by agents. So we feel that we're really bringing value to the customers. We primarily work with very large enterprises. So you could see some of the names on the right side, but it is essentially folks who have a lot of structured and unstructured data that they have gathered over the years. and they really want to mine that for insights and for workflows that are very specific to your enterprise, right? Can move. Yeah. All right. So this is a slide that I made after having had conversations with something like 500, 600 enterprises across the globe. So if you look at the evolution, so on the left, on the first bubble, what you see is the human intelligence stack. This is what folks have been using for the last 40, 50 years. You've had terminals, you've had your presentations, you've had Excel sheets, and this is built for human consumption, right? So if you look at the way a Bloomberg is set up, you've got time series data, you've got charts, you've got various different kinds of visuals, and these are visuals and these are numbers that appeals to the human eye and to the human brain, right? And what a lot of enterprises have done is they have supplied that directly to very powerful frontier models. So it could be Claude, GPT, Perplexity, whatever the case might be, or your own agents that you've built. But it's been on human rails, meaning you've taken the PDFs and the Excels and some of the connectors that a lot of these data providers give you and fed it directly to the agents. And the data is really not agent ready. So as a result, while you see maybe 50, 60% of the tasks being executed to perfection and you feel really great about it, you still have the 30, 40% where it is hallucinated, it breaks, you've got lots of issues, right? And so it's not enterprise grade. And one thinks that, hey, as these AI systems evolve, I think the tasks that they perform will be better. The actual reality is that you really need to re-architect and you need to transition out of the human rails and you need to get into agent-ready data, right? Because what agents understand are entities, relationships, they understand governance, permissions, and things like that. They don't really care about animation. They don't care about the colors or the logos or time series, right? That's not what an agent really cares about, because an AI agent can read millions of rows of data. It can read millions of pages at one shot, but it cares about other elements, not necessarily a PDF or an Excel. So what one needs to do is to really take all of their data sets that you have internally, really make that agent ready, and then you can move to bubble 5, where you've got the entire enterprise data covered. So the tasks that your agent now runs for you is end-to-end, it is auditable, it is reliable, and it is accurate, right? The part that I really want to call out here is that today an interesting statistic is I think this is floating around and you can read about it. The number of agent or the agentic traffic on the web has surpassed human traffic on the web. So we are moving into an agentic world, and it's very important that a lot of the information that one consumes is going to be made agent ready. Move to the next slide, please. All right. So this is the data reality at most of these institutions, right? And if you look at most fundamental equity investors or banks or even the private markets, what you see is you have a bunch of proprietary internal data. So think of your SharePoint, your emails, your SQL databases. In cases we have seen people using Notion, you've got Databricks, you've got Snowflakes, you've got various different sorts of internal proprietary data that only you have, and that is collective intelligence that you have gathered over many years. One can call that your IP, right? Then you have licensed feeds. These are data feeds, which could be market feeds, it could be other sorts of feed, alternative data, and so on and so forth. And then you have data in the public domain, right? So you might have signals from X and YouTube and LinkedIn, Reddit, etc. Now, what you see on the public domain, a lot of the data there has moved much faster in terms of transformation. So there are lots of other companies that have actually made the market, or rather the public domain data very agent ready. So you do have a lot of providers that can give you access to agent ready data on the public domain. But on the license feeds and the internal proprietary data, it is not ready, right? It's not there yet. And a lot of the connectors that you have from the license feeds are not yet ready for complete agentic consumption. And definitely your internal proprietary data today is not ready for agentic consumption. You can move to the next slide. Yeah, so this is what we think is the right stack for the investment management world, right? So you've got your, what we call as the data fabric. So there's all of this public external market data and your internal proprietary data. So you want to really combine these, right? So you've got your enterprise data and pipes, you've got broker data subscriptions, filings, public data. You combine all of that and glue them together. The gluing them together and being able to expose them for agentic consumption is the graph ontology that one needs. And in addition to that, you obviously need the orchestrator and document intelligence to make sure that you're able to capture all of the relevant information from complex financial data. And as you might be familiar, the quality of this data is very varied across the geographies. So, for example, the kind of data that you might see through the SEC filings might be far more structured versus what you see in a developing nation where you might have scan reports and so on and so forth. So the doc intelligence is also super important. Now, the combination of this is what has to be exposed to agents. And you want to develop a stack where this is interoperable, meaning you want to use Claude, you want to use Perplexity, or you want to use the Pascal interface, or you want to use a third-party AI interface, or perhaps you're building something of your own. You want the graph ontology and the cognitive engine essentially to be exposed to any of these interfaces. And potentially you may move to certain workflows which are completely headless, meaning the agent just consumes the information and throws out or completes the task for you. A simple example might be that quarterly earnings has come out. Go find my model on NVIDIA, update it, give me the key deviations from my thesis or from my model, and send me an email or show it to me as a notification, right? So that might be an always-on autonomous agent. But so there are certain workflows where you might move there. There are certain other workflows that you might just prefer to get the tasks done via one of the frontier LLM interfaces. It could be a Pascal interface or your own interface, right? So what we specialize in is to take all of this unstructured, structured data, run our graph ontology layer on top of it to glue them together, and then also have our document intelligence agent run and make sure that you get accurate information. All of this is provided through an MCP or an API to any of the blocks that you see on top. We also think that over the course of the next 2 to 3 years, there'll be lots of cool and new agents that folks might want to build internally at their enterprises because you're closest to your users or you might have a AI counterpart or a team that's building agents for you. So a lot of the very specific enterprise apps and agents can be also created in-house. So you can imagine a world where there's a lot of agentic tasks being completed. Maybe X% of that is done by out-of-the-box agents that Pascal or others provide, and there might be a lot of new agents that you might create internally, right? So we also have an agent builder where you can create your own agents and you can run those, and that becomes proprietary to the way you look at it. Not very different from, if you go back in history and think about your Excel sheets, right? So you've got your own templates, you've got your own ways to look at a company in your Excel template, and one can consider that each template is like an agent. So you create your own agents, complete the task for you, and then you get to really look for newer sources of alpha, and of course be more productive, cover more companies, look at more intelligence across the globe. You can move to the next slide, please. Right. Now, we also think that in a world that is moving so quickly, there are lots of options on what models to use, right? So you want to ensure that you not only optimize for accuracy, but you also optimize for cost. And there's a lot of conversation around token optimization. And we think that we're just at the very start of the token optimization journey, right? So you might have open source models tomorrow that perform really well on certain types of financial tasks. We think that there might be newer models that the Frontier Labs release that are more token efficient, that might be more geared towards the finance domain. So you really want to get the best of all worlds. So what we do is you have the ability to pick and choose the model that you want. We have running benchmarks of what ensemble works the best. We benchmark that not just on accuracy but on cost as well. So out of the box, what you really get is an agent that runs through all of these different types of models that ensures that your task is done, but it's also done with the least amount of resources being used. If we can move to the next slide, please. Yes. So this is a example, a very simplistic example of what it looks like with and without the graph ontology, right? So when you run AI on human rails and you ask for something like, hey, the NVIDIA Q3 earnings are out, can you go and look into it and summarize that for me? You get a generic summary. This is the same summary that everybody on the street sees. Everybody on the sell side sees, everybody in the bank sees. It's all the same, right? Now you layer that with years of research that you may have done, and it's all messy, and it's in your email and it's in your SharePoint and so on and so forth, right? With you doing nothing, if you connect all of that via the Pascal graph ontology, you might get an output that you see on the right side, right, where it's specific to your thinking. It outputs data points, it outputs arguments and signals that are important for you. And these signals can come, of course, from the Q3 earnings, but it can also come from what the brokers are saying, from what you're seeing on the news and so on and so forth. That is a huge difference in terms of what you're looking at versus what a generic summary is. And of course, every fund is different. There are investors out there that care a lot more about what's the earnings next quarter, and there are folks who care about earnings in the next year, and then there are folks who care about the long-term durability of the business for the next 5 years. So the data points that should surface and the signals that should surface should be different for each of them, and that's what the context layer really gives you. Move to the next slide, please. Right. This is also an important slide because sharing a lot of your sensitive research that you have collated over many years is hard to part away, right, so to speak. So what we have realized as we have worked with a lot of these large enterprises is everybody cares about the data being secure. So security is super important. So what we do is to deploy our software as containers within your environment. Think of this very similar to what Palantir does. So we actually take a software, put in your environment, so your data really never leaves your walled garden, so to speak. So our agents run within that, performs tasks for you like a digital teammate. Our graph is deployed inside your environment. We also have our embedded forward deployed analysts and engineers who can help you through the onboarding process. And we think that this is very important because that's the only way that one is going to get around all of the important security guardrails, whether it is via regulations or whether it is just a security posture that your enterprise is going to maintain. Yeah, I think with that, I think I've covered all of the slides. Just a few snippets of what the product really looks like, and we can, you could go through. This is an example of a query that we have run, which says, what was our thinking on a particular stock? How has it evolved since we initiated the position? How has our internal conversations across emails and chats influenced the position? Has our thesis been ahead of the market? And is there any proof of them converging towards our thesis in the last couple of years, right? So what you see here is just a prompt. There's no files, nothing that's given. It says just go and tell me all the discussions that I've had on SC, which is a ticker in Asia. Just tell me what's been the conversation and so on and so forth, right? So the research actually agent has actually gone in, looked at all the emails related to this particular stock, got me a full summary of where the position, what was your position, what did you decide, how was this decided, what did the team say, or what did the analysts say, what did the market say, are we converging, not converging, and so on. And you have fine-grained citations, so every single number that's mentioned here takes you to the exact source, and you could audit how the agent has really gone through the entire process. I think I'm running out of time, so I want to make sure that that I wrap up. But I think there are more examples of the same, querying, just to give you sense that on the right side you can actually see the conversation. I think this is in Teams, and this is what it looks like.
Vibhav, thank you so much. Yeah, we'll begin the Q&A. I think one of the early questions is on, I mean, it can be addressed to you all. If you could talk about what are the main ways to improve explainability of the outputs within each system. If you want to start first, Rohan.
Yeah, absolutely. So I think explainability comes down to a couple things, right? There's repeatability is, I think, pretty core to explainability. Like if you give someone a justification for an answer, you might be able to get them to believe you once or twice. But if that explanation doesn't result in them, if they prompt again with the same kind of context or they say the same type of question, if they don't get the same answer again, it's likely that they will lose trust in whatever citation system you're using. So for us, the way we do explainability is we will surface exactly what pieces of context caused the agent to come to the conclusion it did on your data or on your process. Um, the reason we believe in surfacing context rather than in some kind of like other kind of generation of like explainability is that this is like the true thing that actually explains the agent's behavior. So it is like the legitimate uh, set sequence of tokens that caused your LLM to generate a certain answer. Part of how we see making interpretability accessible to investors, to other stakeholders, to executives potentially, is that instead of feeding in raw context like data or like just like random snippets of code or whatever it might be, we take the time to learn from those raw technical artifacts and convert them into plain language. And plain language works very well as context for LLMs, but also works very well as something that you can cite to a human. So, as an example, we might say, okay, like we decided to use a certain type of data in order to answer your question about an economic thesis you have. And here's some documentation on that data. And that is a link that you can click on and you can go read it in plain English to understand what exactly we're doing. But it is also the exact same context that the agent was hydrated with in order to understand the data, meaning that you'll actually be able to replicate that result if you were to take that context and use it again.
Understood. Thank you for the explanation. Wilson, if you could address it as well.
Yeah, sure. I think explanation is probably the heart of what Permutable does. And I think we've seen over the last year, explainability has gotten much better by the reasoning agents. I think similar to the two panelists, we really focus on the structured data and the knowledge map part of the stack. By doing that, we ensure that all these pieces are very clearly put out to the agent when they make decisions. And then what that allows us to do is it really allows us to pinpoint not only what the narrative is, but all the core pieces it's used to generate those narratives. And then those core pieces will then, if you go upstream in the stack, you will then arrive at the actual raw data, whether it's price data or textual data. But yeah, we agree that accountability and auditability, especially for investment decisions, is that needs to be, that bridge needs to be covered if we're going to be moving into fully like agentic sort of decision making.
Understood. Thank you, Wilson. And finally, Vibhav, if you can tackle this as well?
Yeah, sure. I think not very different from what Wilson and Rohan already spoke about. In our case, to explain what we do is we actually have a planner agent, and you can see the entire reasoning chain. But the biggest advantage of creating the graph ontology is that we parse through every single data file that you have, whether it's a PDF, Excel, emails, whatever the case might be. So, as the planner agent tells you what it's doing, it also surfaces where it's getting the information from. So it might say something like, look, I'm going to read through NVIDIA's Q3 earnings release, and here's the page that I'm looking at. So you could actually click through and see what it's really done. And then it'll tell you whether it found the answer, it didn't find the answer, and so on and so forth. So it's almost like a chain of thought. And a lot of our customers actually prefer going through the chain of thought because it sort of gives you a more in-depth answer in places that you really want to deep dive. So that's how we tackle the explainability problem.
Thank you. Thank you, Vibhav. Next question. What is the process of updating the knowledge graph? What are the trade-offs with stale data versus token cost? No, Rohan, do you want to take this one?
Yeah, so I think all of us have some form of knowledge graph, but we're primarily a knowledge graph company. So the way I think about this is that the knowledge graph is something that needs to be trained. There's a recent study that Anthropic actually did internally where they said something like they built an agent to answer questions about their internal data. They obviously have lots of it, and they found that just by exposing the agent to all of their past notebook studies, analyses, whatever, it only increased accuracy by 1%, but by having a curated knowledge layer, it increased accuracy by 70% or something like that. So it's like huge differences. So because this information needs to be distilled in order to have good performance, you can think of it like a training loop. When new information becomes available, whether that's new theses, new studies, new kinds of analyses that quants are doing or the fundamental investors are doing, all of those artifacts indicate modes of thinking, which can be cross-referenced against how the knowledge base is already encouraging agents to think. Sometimes these things reinforce each other, indicating that nothing has changed. You're still thinking about data the right way. You start thinking about process the right way. You're still thinking about entities the right way. But sometimes you'll find a discrepancy. But if you have a proper training loop, it's relatively straightforward to say like new artifacts are coming in as effectively training. You train on those artifacts and you find that, okay, our direction has shifted. And this is really a point which is not technically difficult, but it's actually organizationally more subtle. So it's very easy to catch when there's an inflection. But then you need the right process around who kind of gets to look at that and approve that the knowledge graph should change. At least the way we do that is we have change point detection built into the training loop. So if, for example, we used to have a thesis that when we're evaluating a certain type of alternative data, it should feed into a certain sector. But then we say, okay, you know what? It's no longer good for this sector. It's good for a different sector. That is a change point. We would actually have a relevant human stakeholder get looped in to provide a human in the loop decision. I guess to answer that question in a more summative manner, we see knowledge graphs as being trainable artifacts, not as kind of static things that you just build with traditional algorithms. So if it's a trainable artifact, it's relatively easy to give it new information and have it train on that new information and update itself. But having a good story around change point detection, human review, and then even if the human review goes wrong, versioning, rollbacks, and the whole semantics of being able to control this like a database or like your source code is where we see the real value. Without that, it's hard to have trust as these things evolve over time.
Thank Rohan. Thank you for explanation of the human loop as well. A specific question for Wilson, I think. So you mentioned scheduled frequent bursts of agent activity. Is that mostly to manage costs, or what's the main reason for that?
Yeah, I think we have a very sort of startup, bootstrappy mentality where we try and force efficiency in terms of like token usage. So we go as far as actually model selecting and getting best ROI on tokens. What we also do is we realize that most of the stack, a lot of the work for agent work can be done deterministically as well. and using smaller models. So running bursts is really one of the final sort of pieces in the plumbing where we realize that we don't want to get into very long iterative loops going around the same task. So we kind of really want to do short bursts to really minimize those sort of run costs. We're processing probably close to about 100,000 articles an hour, and we need to ensure that these agents are processing it in the most efficient way. So the way we do it is the burst is really the final piece of ensuring that we're getting the most out of like strong like reasoning agents. But really the burst sits off the back of quite a large sort of efficiency stack in terms of how we run agents. But yeah, the answer is we'll probably do short. Let's say if we want to make it real time, and let's say real time we accept every 5 minutes is probably good enough, then we can do short bursts of like 30 seconds for agents every 5 minutes, and already that's going to save you a lot of money.
Fascinating. Good to learn about this in internal operations. Another one for you, Wilson. You mentioned autonomous event detection. So what types of events are you tracking? Is it like specifically micro events or
Yeah.
any other types?
So the really interesting use case of agents is that they effectively are state aware, or you can make them state aware. So our big customers right now are, and I think the whole world is looking at like when is oil prices going to come down from $95 a barrel. So there are small clues to this, but you wouldn't know what the clue is unless you have full context. So the clue is when is there signs of there being a ceasefire, given all the bullish data that we're getting in the market right now. So what the system does is the system knows that we are in a bullish regime. It knows that the market is very biased on the long side. So really what it's doing, it's really picking for early evidence that structurally that this ceasefire is actually really happening, and it will be looking for key information. So an example would be the tone of sentiment coming from the Iranian parliament. Okay, so an agent would be able to detect that and would be able to alert traders that there's been a key shift in narrative from the market. And that opportunity is probably worth, I mean, we're talking $10 to $20 a barrel on that. So we're talking really nearly 25% like readjustment in price. So these kind of key little subtle narrative shifts is something that agents are really, really good at doing. And then we deliver that, at the right point in time when it's realized.
Super interesting. Thank you so much, Wilson, for explaining that. And then I think we have one more question. Time for one more. Vibhav, it's for you. You mentioned multimodal LLM orchestration. Can you explain how you came up with the different combinations, how you were testing these?
Yeah, sure. So we do weekly benchmarks of any new models that are out there, and what one typically hears about is from the Frontier Lab, but there are many others, SLMs, there are open source ones, and so on and so forth. So we do weekly benchmarks. And what we would also figured out, as we have done these benchmarks is that, you don't really need an Opus 4.8 for a simple data extraction task, and you might be okay with like a model that's at least a year old, or if not more than that, right? And from a token usage perspective, it is probably 5x or 10x cheaper. So when we run these benchmarks, we also benchmark them to the different tasks, and all of this comes into play within the orchestrator. So we call the right models at the right time, depending on the task, to make sure that that it is token optimized. But the evaluation of these models typically fall into three buckets. There's a bucket where we use some of the standard evals like Finance Bench and so on and so forth. We have our own golden set where we think are the most important questions that our customers typically ask, and we benchmark against those. And then third is we have nominees from our key customers, and probably something like 50 odd customers who typically look through this and give us an eval as new models come out or we change the ensemble. So those are the three ways that we capture the signal, and then we decide what's the most, what is the best given 100% accuracy at the lowest cost.
Amazing. Thank you. Thank you so much for the details. I think we're at time now. And I just want to mention that the recording of the session will be available in the coming days with some summary notes. Thank you again for this hour to all the speakers. And see you soon in our future webinars. Thank you. Thank you again.